Gases, chapter 11. So here's a picture of a little boy, and he's got this really long straw sipping soda. So the author wonders, well, what if you made a really, really long straw? You maybe have tried this at a restaurant when you were a kid. You stick the straws together, but they always leak a little bit. And if you suck on a straw too hard, it sometimes will collapse. What if you had a perfect straw? And you put a cup of soda down in the courtyard, and you stood on the roof of the building, and you had a straw that went all the way down in there, and it was rigid enough, it wouldn't collapse, and it wasn't going to leak or anything. Could you suck soda from the courtyard to the roof of the building, basically 3 stories tall? No, you can't, because the building's taller than 32 feet. And even a perfect vacuum will not pull it up higher than 32 feet. We're going to understand a little bit about why that is. Did you ever wonder how sucking on a straw pulls the liquid up anyway? What's going on with that? There's a lot of things in our everyday life that we're just so accustomed to, we never actually think about, well, gosh, how does that work? So there are molecules in the air, a lot of nitrogen, some oxygen, and those are pressing down on us. We don't feel the atmospheric pressure because we're accustomed to it. We would notice if it was gone, but we're accustomed to it. Just like, you put your clothes on. When you first put your clothes on, you feel them, right? You notice that they're touching your skin, but then you get used to it, and you don't feel your clothes anymore until you start thinking about it, because I'm talking about it. Now everybody's feeling their clothes, right? It's like, ooh, my shirt's scratchy. But the air is pressing down. It's pressing down on the liquid. When you suck on the straw, you are removing the air that's in there and creating a vacuum. The atmospheric pressure pressing down on the liquid is what's causing the liquid to go up into the straw. And so there is a limit on how far water or any liquid can be sucked using even a perfect pump that can pull a perfect vacuum. It'll only go so far. The atmosphere is actually pushing the soda up your straw. So 34 feet is about the limit for sucking water. Can't go farther. Because at that point, the force of gravity pulling down is equal to the force of the atmosphere that's pushing the water up the straw. It'll go up to 34 feet and it won't go any farther. Now, I had someone ask me, and when they asked me, I didn't have a good answer for it, but I thought about it later and I figured it out. So what about a well? So around here, if you live outside of town, you don't have city water, you have a well, right? And some of those wells they're like 200, 300 feet deep now because that's how low the water table's gotten. Well, how can the water be pumped up more than 34 feet? Well, it can't. It can't be pulled up. It can be pushed. But that's why the pump is lowered down into the well. The pump needs to be down within 34 feet of where the water level is. The pump can then pull the water up using suction, and the rest of it is pushing. I thought that was interesting. So gas particles are just bouncing around, and they exert a pressure. These little teeny tiny gas particles, but when they run into something, they exert a pressure, just like somebody punching a wall, it's just much less. So the gas exerts a pressure that's on average 101,325 newtons per square meter. Probably doesn't mean a lot to you. Or 14.7 pounds per square inch, that's PSI. PSI is the abbreviation for pounds divided by square inches. That's the average pressure exerted just by the air around us. You suck on the straw, you lower the pressure. The pressure outside compensates and pushes the liquid up. The difference in height here is representative of the difference in the pressure on the inside of the straw and on the outside of the straw. So here we have a pump, perfect vacuum, no leaks or anything. The pressure exerted by our atmosphere is 14.7 pounds per square inch. When you get this column of, he's talking about orange soda because apparently he really likes orange soda. I would change it to Diet Dr. Pepper or Rockstar Zero Punch if I had a choice, but whatever, it's orange soda. When the column of the orange soda being sucked up into this straw reaches 10.3 meters, about 34 feet, the pressure exerted by that is also 14.7 pounds per square inch. The pressure of the weight of the soda. So the weight of the soda pushing down is equal to the weight of the atmosphere pressing down, and so it won't move up any farther. Any questions or comments about that?